guys, just checking in. Can you guys hear me correctly? Can you see the screen correctly? Just checking in. If anybody can say that in chat.
Yeah.
Okay, that's cool. Thank you, whoever that was. Yeah, we'll try to make it very interactive and stuff. We're just having a few technical problems, so don't worry about it. Real quick, you know, even the best make mistakes. And oh yeah, take this one off up there. Okay, just real quick. My name is Davide. Over here. Maria is going to be with us in a few seconds. We're going to run the the Micro.lab today, as you all can guess. A little bit about me. I'm a BM second-year student. I used to be in BM as well. I did the course change, so in case anybody has any doubts regarding that, I know it's still your first year and you still have a lot of doubts and stuff. But in case you have anything to ask about that, please reach out to me. This is my Instagram, and I also used to be in course rep as well, so you can also ask me anything about anything you might have. And Maria, right now, she's a second-year BM student. She's course rep right now, and she's also very, very available and stuff. She's also very kind. She will be okay with answering any types of doubts you might have. When are we starting?
Yes.
Okay, are we starting? I'm gonna have to take the mask off because Maria's gonna get closer. We're gonna have 4 true/false questions to each. So it's 2 for me, 2 for Maria, and we'll go over some theoretical topics as well as like usual questions. Your exam is gonna be online, as everybody's. So general suggestions about the exam. First of all, I would say that the most important thing is that you guys get your theory right. It is extremely important considering that you're going to have very few calculus to do, very few computations and stuff like that. So they're going to be very, very heavy on, theory overall. So get your theory right. It's going to be very, very easy. It's legit cash on the table, so you have to get it. So it's points that you have to take. On top of that, the calculation you're going to have, they're probably going to be fairly easy considering you're not allowed to bring a calculator as well. So and this might be like kind of straightforward for most of you guys, but I'm just saying it out loud because these are like the types of things that make you lose points. So Maria's going to come in right now.
Hello everybody, thanks for coming. And really hope this session will be useful for you. And we're happy to start with the first part.
Cool. I'll leave her to the first true/false questions, then we'll switch. Obviously, don't hesitate to ask questions. We'll look over at the chat as well. And yeah, just have fun.
Okay, so the first question is a true/false question. And we're going to send you the PDF of all the questions when the session is over, so you can all read. So, but meanwhile, I think we can get this off there far away. Meanwhile, I'm going to read the question from my papers, and then we're going to sum them together. So the first question is a true/false question, and this is the text. Frank considers x and y to be perfect substitutes. Thus, he is always equally satisfied with either basket A with 2 units of x and 1 unit of y, or B with 2 units of x and 2 units of y, where the first number refers to the amount of good x in the basket, while the second number to the amount of y in the basket. So I'm just gonna write this so you can all understand. Okay, so first of all, to answer the true/false question, we really have to understand what perfect substitutes means. As you know, there are 3 types. The goods can be related in 3 ways. They can be independent, complements, or substitutes. And this is our case. To answer the true and false questions, we have to understand what is the marginal rate of substitution between the two groups. Because in case the two groups lies on the same reference curves, then the statement is true. So the two baskets are equivalent, and Frank is willing to switch from one to the other. He's willing to switch from one to the other because they are substitutes. So he doesn't have preferences for one over the other. But we have to understand what the marginal rate of substitution is. So we have three cases here. Case 1, when the marginal rate of substitution is greater than the basket opportunity cost. So the price of X over the price of Y. And this is the case. We have the budget line, and this is the reference curve, and this is the optimal basket. In case 2, we have that the marginal rate of substitution is less than the opportunity cost, and therefore, in the graph, this is our preference curve, and this is the optimal basket. While in the third case, the marginal rate of substitution equals the opportunity cost. And therefore, in the graph, the budget line coincides with the preference line. So in this case, all the baskets lying here are optimal baskets. So to answer the true or false question, and since we don't have any information related to the marginal rate of substitution or to the opportunity cost of the basket, we must say that the statement is false or uncertain, because if this is the case, then it's true that Frank is always willing to switch from a basket with 2 units of A and 1 of Y to 1 unit of X and 2 units of Y. But if this is the case, or this is the case, then the statement is incorrect, because it's not the same for him to switch from basket A to basket B and vice versa. So if you have any questions, just write in the chat and we're going to answer them. Otherwise, Davide, it's your turn.
I'm just gonna run through the second exercise right now, and give you some tips regarding how to approach these kinds of exercises, because although it might look easy at first, this is where most points are lost. So pay attention to that, and thank you first of all. So we have the second exercise, the second true or false, which says Andrea's demand for a good Q is represented in the figure. At the vertical intercept of Andrea's demand for Q point Z, the price elasticity of demand equals -1. So I'm gonna just draw the graph real quick and we'll reason through that. We have the usual P and Q, so nothing too fancy here. And the demand is here. And the point Z here. So this exercise is pretty straightforward in terms of calculation, because the guy here is talking about the price elasticity of demand, and we just have to know the formula. So that's what I was saying. Basically, you have to pay attention to the kind of theory that you know and the kind of theory that you don't know, because it is very important to get it right. So here, the price elasticity of demand. So pretty straightforward. Again, is the derivative of the quantity over the product times P over Q. And as you can see, it varies between different points from one point to another. So we have to pay attention to that as well. This is the formula to calculate it throughout the line. But you have to pay attention to just the math, right? Because here, what the exercise is asking is basically what's the value of the price elasticity of demand here, And as you can probably guess, as of now, this is just an exercise of pure math. So as long as you can understand that here, the value that this thing might have is going to be like 0 and any type of price. This is the key point of the exercise. You basically have to understand that at this point, you have the value of x that is equal to 0, and this is straight high school math. So I'm not here to teach you that. But you have to understand it because it's really where the whole exercise revolves around. And now, if you plug in, let's say you have 0 and price over here. So in the price elasticity of demand, you can already understand where the exercise is going. Obviously, you cannot like theoretically divide by 0, but let's say this number here tends to 0. I hope you guys can see real quick. And so Q tends to 0. This thing instead is is positive. We have the price that is going to be like anything. So you can already understand where this is going because this. In any case, you can already understand that if this thing goes to 0 and this is positive, obviously this thing is positive as well. You're gonna have the elasticity of demand that in absolute term is going through infinity. So you can already understand that the exercise here is false. So just to be real clear, the exercise, the true false here is false because at the vertical intercept, basically you have that this thing is going to 0, therefore it brings the whole fraction up to infinity, obviously in absolute terms, meaning that what the exercise was saying, that is that the elasticity of demand is equal to -1 is not true. Now, just some theoretical things related to this. In case, when the demand of good is linear, you have that the price elasticity of demand is basically non-constant, as you can grasp through here. And this is really important to understand because you have to kind of understand how the price elasticity of demand moves throughout the graph. And as a matter of fact, in absolute term, so my advice is just bring the absolute value. It's always easier to reason on absolute terms. This is positive terms because you don't have the minus, you don't have any other unknowing things. And you can understand that as long as you keep going down, so if you move up down along the curve, the price elasticity of demand decreases. Again, I'm going to underline this in absolute terms. So I think I said it too many times. But yeah, in this point, the overall question is false. And it is very important for you guys to understand how the price elasticity of demand relates to the position of the graph. So I'm sure you guys will get it right, and we'll get right through the third exercise right now. Okay.
There's a question. If Q is going to 0, why does it bring it all to infinity in absolute terms?
Because, so basically here, we have to get the limit of, let's say, a over x, as x goes to 0. Since this thing is at the denominator, so let's say you have a number that here is positive, and here the number is 0.000 whatever. How many times is 0.00 whatever here goes to infinity, again, in absolute terms? Because in case we had, for example, here a minus, and this wasn't in absolute terms, we would have had, for example, an exercise that would have said like the whole fraction goes to minus infinity. So this is just like straight math. I'm hoping I'm not confusing you guys. But yeah, this is the exercise. In case you have any doubts, I'll be answering them also through the CM. We'll just get right through the third one.
Okay, guys, so since some of you asked for it, we're going to share the PDF with all the exercises so it's easier for you to follow from home. And we're now going to do the true or false question number 3. So the text of the exercise is this. John reacts to a reduction in his wage by working less. Then for him, leisure time is an inferior group. So I'm just going to write it so it's easier to follow. The wage decreases, and he reduces his labor. Then leisure, which is the end, is an inferior. So to answer this question, we have to analyze what the income and the substitution effect do when there is a reduction in wage. Usually we study this phenomena when the price decreases, and we study the effect of a decrease in the price of X on the quantity of X consumed or bought. Now we're going to do the same using wage as the price for leisure time and labor, because of course the more you work, the more you earn, and then you have more money to spend and less to spend. The two effects are the substitution effect and the income effect. The substitution effect is the one that measures the change in leisure time resulting from a change in the opportunity cost. So as the opportunity cost of the good increases, the consumption of the good decreases. But the income effect is opportunity cost. While the income effect is the one related to the purchasing power of the buyer. So as the purchasing power increases, the consumption of normal goods increases, while the consumption of inferior goods decreases. So now we have to study these two effects on the situation we're analyzing to understand whether the leisure time is an inferior good or a normal good. So we can draw the usual table. I'm sure you've done it in class many times. So here we have wages, substitution effect, which is income effect or purchasing power. So if N is an inferior good, as the wage decreases, because we are told at the beginning that wage decreases, and labor decreases, then the effect on leisure time is that leisure time increases. And the same happens here, because as this one decreases, as the purchasing power decreases for labor, then the net effect on leisure time is that it increases. So the total effect is that it increases if N is an inferior good. Now consider the case when N is a normal good. Okay, so when N is a normal good, in the same way as the opportunity cost of N decreases, N increases, and we have no problems here. But then, if the purchasing power decreases and N is a normal good, it should be that N decreases, because since the buyer has less purchasing power, it can virtually afford less leisure. So the total effect here is uncertain, because it depends on the two relative effects. What do I mean? We have three different cases. In the case in which the substitution effect and the income effect equal in absolute terms, then the final effect is that there is no change, because these two offset each other. If we have that the substitution effect in absolute terms is greater than the income effect, then this one is the one prevailing. So at the end, leisure time will increase. While if the substitution effect is less than the income effect in absolute terms, then the overall effect prevailing will be this one, and then the leisure time will decrease. So to go back to the question was if the wage decreases and John consumer less labor.
There is a question.
Can I answer just? I'm really close to the other side. Okay. Then labor decreases and is an inferior good. Well, it is not that labor decrease. It must be that then leisure time increases. but we have seen that leisure time can increase either year for year. So it may be that leisure time is an inferior good and therefore it increases, or it may be that leisure time is a normal good and it increases because the substitution effect is greater than the income effect. So this true or false, of course, like false because we're or uncertain because we're not sure that n is an inferior good. It is, but it may also not. Okay. So that is going to ask for false, and then we're gonna pass to longer.
Sure. Okay. Real quick, this last exercise is pretty similar to last group. It's pretty similar to the one we've already dealt with, except we're not talking about wages and leisure time. We're talking about goods. So we're talking about inferior and normal goods. So I hope that the last one was clear enough. I'm just gonna get the exercise here real quick. So just to be clear, we're on true false number 4 of the file. So number 4. And it says that the price for good X rises. Affordable consumption spots gets lower, and when prices budget line pivots inward, as shown by the arrow in the figure, which I'm going to draw right now. Following the rise in the price for X, the price shifts her initial best choice from E1 to E2. Then the substitution and the income effects of the rise in PX and the quantity of X consumed work in opposite directions, with the substitution effect affecting the income effect. So real quick, I'm just going to draw the graph we have here, which again, two goods, the X and the Y, which are in the usual places. So this one is the initial best choice. So E1, I'm just going to be initial best choice. And we have that this one over here, E2, is the new best choice. Now, what happened? We have to use basically deductive reasoning. What happened is we have the first point, E1, with values x1 and y1. And for the second point, E2, with values x2, y2. I hope this is clear enough. In case you don't understand anything, just write in the chat, we'll get right for you. And what we can understand from here is that the key point here is that x2 is more than x1. While on the other hand, y1 is, well, as you can see from here, also more than y2. So this is the key point that you have to get. Because out of this, you can understand how the two baskets get varied with this little price change, which, just to write it real quick, is Px goes up. So this is what happened. We have the price of X going up. We have the consumer doing this. Okay, the price of X is going up, so I'm going to actually be consuming more of X and less of Y. So this is basically how the situation unfolded, which is pretty not intuitive because, well, the price of good rises and I keep consuming more of that, right? Of that good. So it doesn't really make sense. Well, to be fair, it does. You just have to know a little bit of micro. And as a matter of fact, good X turns out to be a given good. So what is a given good? Given good, real quick, is just a good that when you actually increase its price, well, you keep consuming more of it. And, well, theoretically, these types of goods don't really exist. I mean, that's why, well, that's what they probably told you. Even though if you look them up on the internet, if you're interested about them, there are some examples, and it's a borderline case. But anyway, getting back to the exercise, we understand here that X is significant good, which is pretty important compared to the overall problem. But regardless, we're going to be analyzing again. So let's cancel these things out. We're going to be analyzing again what happened. So we have that x2 increases and y instead goes down. So for the, well, I'll just draw real quick the chart. So as we done before, which is pretty vital. I mean, you might as well tattoo this chart to your arm, or I don't know, in case you don't remember it, because it's very, very important, as I said. So yeah. So as we've done before for wages, but this now is regarding goods. We have the price of X increases if X is a normal good and if X is an inferior good. So this is pretty straightforward, right? And the substitution effect and the income effect. Now, needless to say, substitution effect is governed by the opportunity cost, which is P of X over P of Y. That is pretty important concept as well. It's going to be also very useful in your next subjects. Also, if you go to studying like anything else other than micro, these types of concepts as well as demand and supply are going to be very, very useful. So learn them not just for the purposes of the exam. I mean, if you really have to choose something to learn and something not to learn, choose these things. So the substitution effect, opportunity cost. Well, on the other hand, the income effect depends on the purchasing power. And it's pretty straightforward, right? I mean, the price of a good increases, you have less purchasing power of the good, so you can buy less of it. Same thing, the price of a good decreases, you actually have more purchasing power of it. So real quick, the way they interact is this one. Let's say the price of X as we said goes up. Now what happens is for the substitution effect, you have higher opportunity cost. So sorry, yes, a higher opportunity cost, meaning that you basically can you're able to buy this good, but you're actually able to buy more of the substitute good, the other good that you're considering in the basket, which in this case is a good Y. And for the income effect, is said if the price of X goes down, here's where like the differences arise. Because in case we're talking about a normal good, if the price of a normal good increases, you're actually going to be consuming less of it. Well, if the price of a normal good increases, an inferior good increases, you're going to be consuming more of it, right? Okay. So this is the way it folds. So, well, clearly, yeah, X goes down here, and this is uncertain. Just real quick theory recap. You guys already had it with the wage and labor time. So I'm just gonna real quick just get you into the overall theme. And also another thing that is pretty relevant in terms of the overall exam structure. I want you guys to remember what an angle curve is, because it is very about goods. So an angle curve is basically a curve that actually allows you to understand how the income, I'm just drawing it right now, how the income relates to the quantity of a good. So real quick, I hope this is clear. In any case, you can find it on your book as well. And what you can find is that, for example, if you increase the income of the good, the income of a person, and you're talking about an inferior good, then this person is actually not going to buy any more of that good. And well, this is not really straightforward, right? Well, let's say just a more practical example. Let's say you buy, well, the usual example they give you is potatoes. But I know some of you might like potatoes, so I'm not going to enter that. Let's say you go to the Estelunga and you find smart products. Smart products are like the low-cost thing that Estelunga offers, and they have their values. I'm not going to argue about that. They have their good thing. But anyway, let's assume you're poor now, but tomorrow you win the lottery. Are you still going to buy smart products? I don't think so, right? So what happened is your income has increased and you've actually consumed less of them. That's an inferior good. So real quick, just when you have to put an example, I mean, you don't really have to show off that you know about smart products, but this is just a lot of improvement. Well, on the other hand, let's say you like jewels. Well, you probably do. And your income increases, then you're actually going to be buying more of them. So this is not an inferior good, this is a normal good. And this is actually to allow you to understand how income influences all purchasing decisions. Regardless, about the exercise, which I will come home real quick. And what I was trying to tell you about is the angle curve that allows you to understand how the income good relates to the overall quantity purchased. So you can find it on your book as well. I'm sure your professors have already dealt with it, but just so you learn about it, these are the really niche things that they might be asking. Because, well, this is all about Bocconi being very annoying about their exams. And yeah, just for the sake of the exercise, here what it is saying is that when the price of good X rises, as we've done before with the chart, which you already have because you did it with in the previous exercise, the exercise is saying that well, when the price of good X rises, the substitution effect is actually offsetting the income effect. And as you can understand already, this is false. Why? Because, well, the new best choice, as we already kind of examined real quick, x2 has increased, so x has increased and y has decreased. So we have that price of x increases, but x actually is increasing, as well as y decreasing. So what we have here, as I said before, is a given good for the consumer. And as a matter of fact, the income effect and the substitution effect, well, they work in opposite directions, but the income effect is actually, so as x increases, is actually more than offsetting the substitution effect. So what happened here is that not only is x a given good, but it's income effect, so the way that purchasing power actually matters in consumption decisions regarding that good is way stronger than the substitution effect. And this you can already understand it from the graph. So once again, this is all about getting the first intuition right, which is understanding where the position of these 2 points relate to their quantities. And again, this is just high school math. So I'm sure you guys already got that program. But in case you have any questions, as I said, get right into it. Pretty easy exercise. So okay. I'm gonna hand the word to Maria. No. I was joking. It's still gonna be me because the first exercise is still me. So you're gonna have to bear with me for a while again. Well, and this exercise is about, as you can already say, production decisions. So nothing too fancy again, but again, I don't even think that you might be getting especially these types of exercises again because they have numbers. But as you can see, like the numbers they have, they're really simple. They're not like anything fancy whatsoever. So you might be getting something like that too. So what the exercise says is first produces good Q using the production function, well, Q of K L equals to L to the power of 1/3 times A to the power of 1/3. Where L is labor and K is capital. Well, the marginal products of L and K are these ones, which again, they're just the partial derivatives, but I'm aware that you don't need to do them for the purpose of the exam. But just a heads up, we're going to be pretty much a pain in math 1. But you don't care right now, you have other efficient fine. And yes, these are the two data. And the unitary cost of labor is, well, this is right here. W equal 5 and K, sorry, R equal 2. Right? I hope everybody's following. We haven't done it. So, well, provide the first question is provide a suitable definition for the following terms. Well, marginal rate of technical substitution and isocost curve. Oh, guys, if you knew about the difference curves for goods as well as marginal rate of substitution, you basically just need to change the names here. It's pretty easy. So, for example, we have the generic price isocost is the total cost of Q is equal to, in this case, well, a generic total cost Q would be WL plus RK, which is pretty straightforward, right? How many units of labor you have times how much 1 unit of labor costs you, as well as how many units of capital times how much a unit of capital costs you. So again, nothing too fancy here. Micro is all about this. And it's all about not making stupid mistakes regarding calculations in theory. In this case, however, we just have to plug in what the problem is giving us. So 1 unit of labor costs 5. So this is our cost for labor. It's going to be our total cost for labor. And 1 unit of capital costs 2. So this is going to be our total cost for capital. Again, pretty easy. And again, what we're going to be dealing with now is the marginal rate of capital substitution between labor and capital. So once again, you remember that the marginal rate of substitution for good is equal to the marginal utility of x over the marginal utility of y. Well, here, what we have is the marginal product of labor over the marginal product of capital. So you just have to plug in the values, which are, I'm just going to get them all over it, are these two. So just plug these in. We're going to get what? And just a general suggestion, most of the time, these numbers, like, I don't know, cross out, they simplify, and they're just, you get like pretty hard calculus at first, but then it becomes easy. And as a matter of fact, this is the K over L. So, and just to be clear, the marginal rate of capital substitution is how much like capital the firm would be willing to give up for 1 unit of labor. Again, technical substitution, pretty like intuitive, right? And this is the first question of the exercise. So I'm just going to cross that out. Again, it's very much about like knowing the very simple things, and you can get pretty good like understanding of the whole problem. Secondly, we are told, I'm just gonna write again here the 1/3 K 1/3 our production function, as well as our total cost function. Sorry, this one here is total cost KL. My bad. KL. So it is 5L plus 2K. Right. The second question we had is, suppose that in the short run, the firm is endowed with 10 units of capital. So we have that K1 is equal to 10. And find the minimum cost that the firm will have to pay in face to produce 10 units of output. So Q1 is equal to 10. Right, so what we have to do here is, we'll understand what the short run and long run mean. Well, short run is basically when you have one of the 2 units, so either labor or capital, or like, you can do that with like 500 like units as well. If one or more of them are fixed, well, it means we're in a short run. And in this case, we have capital that's fixed. So you have to understand that in the short run, you have one value that is fixed. In comparison, in the long run, instead, we have 2 values that vary. So just real quick, this is a very straightforward definition. So again, we can understand our production function in the short run by just substituting the type of data we have. So it's L to the 1/3 and 10 to the 1/3. Again, nothing too fancy. And in order to produce like 10 units of output, just put it like input here, because this is output, right? And this is what we get. So here, you can already understand that your only variable is L. You have a very like easy equation. I mean, you're gonna have to play with like numbers and stuff. So this is 10 to the 1. This is 10 to the 1/3. So you're gonna have to divide everything by 10 to the 1/3, or like just elevate everything to the 1/3, to the third power. It doesn't matter. Like I'm not here to teach you math again, but you should be alright with this. And what you get in the end is that L. So L1 in this case is equal to 100.
How do you get the K is the?
It's the problem tells you that you don't have to compute it. They're saying they're actually, so the question is how do you get that K1 is 10? What happens is the problem tells you, okay, K1 is 10. Find the Q. You don't have to compute it. So they've already told, like in that case, it could also been L1 is 10, or like any other production variable that you have. So yeah, and you just plug that in, and you get the how many quantities of labor you're actually going to have to use. And well, since they want the total cost and the minimum cost as well, since we have our function here we have a function for total cost with generic numbers. This one over here. Now you're just going to be plugging in the values you got, which are 10 and 100 over here. So yeah, again, just a matter of multiplications, which I don't know if you're going to actually be getting, but again, these types of multiplications are fairly easy as well. So you have 5 times 100 plus 10 times 2. So this should be 520, which is the end of the second question of the exercise. Again, when they tell you about the minimum cost, obviously you have to compute exactly what you should be getting from here. Because the minimum cost doesn't involve you actually having more units of labor. It wouldn't make any sense. That unit of labor that you have in surplus would be actually wasted. So that would be the minimum cost. So just don't think about this. Plug the numbers in and real quick and understand how it goes. Well, we're going to get through the third question in the exercise. Now we're in the long run, so I'm going to have to QKL, L1/3 and K1/3. Okay, and again, the total cost here of KL is 5L plus 2K. Now, the third question says, suppose now the firm operates in the long run. So just be clear now, we're in the long run. Previously, we're in the short run. And that's when you have 1 unit fixed. So in that case, it was K. So power K1, for example. Find the minimum cost that the firm will have to face to use 10 units of output. So we have to find the minimum cost such that Q is equal to 10. And we have to compare the results with those found on point 2. So regardless, in point 2, we found that the total cost of K1, L1 was 520, with K1 equal to 10, and L1, which is the one we computed, is 100. Now, what happens is you have to understand that this, in the long run, actually, we have the 2 variables. So K and L are not, any of K and L are not fixed anymore. So we're just going to have to play with numbers real quick. So we have to understand how to produce the desired number of output, meaning that how can we get this thing to equal 10, which is the desired unit of output. So it's going to be like 2 equation system here. So 10 equals L to the 1/3 and K to 1/3, which is pretty straightforward, right? Like, how many units of labor capital do we need to get to 10 units of output? And for the total cost instead is, well, we just have to understand, use the marginal rate of tactical substitution, which we computed previously. So this real quick is going to be K over L, right? This is our marginal rate of tactical substitution. So this is going to be like, play a big part in our second equation. So for example, we have K over L here, and by this one, you can already end up understanding that if you multiply this one by the marginal rate of technical substitution, you get over F R. Meaning that as the overall problem sorts out, means that basically you have the 10 units of output as well as doing that at the minimum cost. So given basically the production technology, you basically have the overall the overall conditions that turn into this system, which is already basically laid out. I usually skip the bigger system part because it's pretty much a nuisance, but you can already understand how it goes here, right? And now, if we substitute the values that we have, so this Q1 equal 10, which is this one, right? Marginal rate of substitution, these are the two variables, which include K and L, and also W over R. These ones actually turn into what we have here, what we need here. So L and K. So basically, what we end up having is just going to be doing. I'll just cross real quick and do the.
I think that this one with the margin with the
Okay, so basically, the first one is, as I was saying, the total cost. So L to 1/3, K to 1/3. This one. And the second one would be, so the first one is the isoc one, and the second one is the tangency condition. So meaning that the marginal rate of technical substitution has to be equal to K over L, right? So I hope this is clear enough. So basically here, what we have is the tangency condition between the isoc one and the isocos curve. Because as we remember, just like in split numbers, so isocos has to be parallel. Sorry, well, to be fair, it is tangent, but in that case, it's actually parallel to the isocone curve. And yeah, I skipped that part as well. So basically, our isocos is this one, the isocos is this one, and the isocos, just we get it through here, as well as our function over here, right? And when we end up, I'm just going to do the calculus real quick. So it is L to 1/3, K to 1/3, okay? Right, yes, times K over L, which is, right? So, well, the tangency condition is basically what you can find, which is means that K over L has to be equal to 5L plus 2K. And then you actually plug that one in here, and you can already understand that you get through this point, 5/2. Now, just being very, very quick about it. So the total cost of producing 10 units of 10 ends up being equal to, wait, where is it? Sorry. Okay, so 10 ends up being equal to L to the 1/3. Yeah, I'll just keep it again. Yeah, sorry, the board is not that big as well. So it is 10 times L to 1/3 times L 1/3 times K, which again becomes 2 times. Now we get through here. So the calculus is really annoying, but you won't be having this, like, most likely in your own tests. So that's a good thing. But what you should be understanding from here is the main principle, which we're going to get through real quick. And from this one, you get basically that L is equal to 20 and K is equal to 50, which I'm calling L star and K star. Just to be clear here, what we've done is we use the K-mix condition, so isocos and isoquant, as well as our production function that we had, which is basically it. So that's how you build the system. And that's basically like how you solve the entire problem. Now, just plug these values into our isocos, meaning that we end up actually having to multiply 5 times 20 plus 50 times 2, which again should be like 200 or something. So this is our value. And what you can understand is, in the long run, it costs, so since it told you to actually confront the values you had before and now, in the long run, it costs less to actually produce 10 units of output, while in the short run, it costs more. Why is that? Because obviously you have that basically in the short run, the cost, well, K is fixed, so you have to keep up with that number of K. While on the other hand, since K is as a short, like a lower cost, you're gonna actually be forced to be spending more labor, which has a higher cost, like higher marginal cost to be precise. So if you have to like do a reasoning about it, you just have to look at the numbers and explain the reasons of why the overall well, the numbers are different. And here it's pretty straightforward. You have a fixed K, you cannot use more of it, but it costs less. Now that you're in the long run, you can use more of it, meaning that you can actually have like more units of K, which costs less, but I'll help you produce more. So yeah, this is the exercise. I hope it was clear enough in case you have any questions. Please hit me up.
Sorry, one quick question. So when you multiplied by K over L, I still didn't get why you...
Sorry? Okay. Oh, wait.
So
Could you repeat the question?
Yeah, sorry, could you repeat it? Yes.
yeah, so when you had the marginal rate of substitution, right? And then you wrote like 10 equals L to 1/3 times K to 1/3, and then you said times K over L.
Wait, I cannot hear you.
Talk again?
Yeah.
When you multiplied the L to 1/3 times K to 1/3 times K over L.
Let's try it. L to 1/3, K to 1/3. Yes.
Yeah, and then you multiply that by K over L, and you got like 5 over 2.
Yeah.
So why did you multiply by that? By the marginal rate of substitution?
Okay. So basically, the question is, I hope everybody could get that. You basically have he asked, why did I multiply by the isoquant by K over L, which is the marginal rate of technical substitution. Again, this is an approach that stems from this one. Isoquant parallel to isocos. Okay, and here isoquant again. So what you can understand from here is that what is your isoquant? I'm sorry, what was the name of Luca?
Yeah.
Okay, yeah, I'm just gonna address you just to be real clear. So basically the first equation is the isoquant. So the second equation is the isoquant associated to the desired level of output, meaning 10 as equal to L to 1/3, K to 1/3. And the second one is the KMHC condition. So marginal rate of substitution, K over L, right?
Yeah.
Okay, So what you end up doing here is, since the marginal rate of substitution is basically how many units you would swap of K times of labor for a unit of capital, you basically end up having to multiply this one by K over L. So this, you divide this one also by K over L. I hope this was clear enough.
Yeah, thank you.
Okay, cool. So,
Thanks a lot.
I'm not sure whether like the approach they give you, because it depends basically on the professor as well. So what I can tell you is one professor usually tells that you have to skip that part and just go to the not system part as well. So I'm not sure if you're familiar with that approach. In case, it depends basically on the professor. So I would say stick to what your professor told you, because there are like different ways of approaching these types of systems. So I don't want to like be confusing you with like external ideas that you might have from different professors. So in case you have another approaches that's been given you, just make sure to use that. But regardless, you're not gonna be using like these types of calculus in the exam this year. So you don't have to bother about it. Just remember that the key point is the tangency condition, okay? I hope it was clear enough, okay?
Okay, thanks a lot.
No worries.
Okay, so now we're gonna start the second exercise, and I think it's gonna take less than what Davide take, but anyway, let's read the text together. So, the market of electronic cigarettes in Italy has a lot of buyers and sellers, and none of them is able to affect the market price. It has no entry barriers, and it is characterized by perfect and complete information. So we are under perfect competition. The demand for electronic cigarettes in Italy is given by Q equal 18 minus the price, while the supply is equal to price. So the first question is, find the market equilibrium, price and quantity, and plot it in a graph. Compute the consumer and producer surplus at the market equilibrium. So to find the market price and quantity, we need to equal the demand and the supply, because this is when the market is in equilibrium. So we simply solve the system. So we have 18 minus P equal to 2P. So 18 equal to 3P, and price equal to 6. To find the quantity, we simply substitute 6 either year or year. And so the quantity of cigarettes traded is 12. So this is the first two informations we have. Then we have to plot the functions in a graph, and I don't think you're going to be asked to do this in the midterm, but we can do it anyway. So to plot the functions in a graph, the thing is that the graph is done in this way: price on the vertical axis and quantity on the horizontal axis. So to draw the two functions in the graph, you have actually to use the inverse functions here, because like here you have Q equals to P, and you need the opposite to put in the graph, like as it was Y equal X over 2. So we simply do this. The inverse price one is 18 minus Q, and the same is like this. So we can plot it in this way. So this one will be a straight line with a positive slope, and it's this one. While the one for the demand will be a negative, like a negative slope line with a slope of -1 and vertical intercept and horizontal intercept of 18. And this is the equilibrium point, in which we have 6 and 12 units. So 12 units here at the price of 6. Now we are also asked to compute the consumer and the producer surplus. So we can do that by considering this as the consumer surplus, and this is the producer surplus. Because the consumer surplus is what the consumer is willing to pay minus the price he actually pays for it. So I'm just going to write it. Okay, we have just here we put the price. So the consumer's surplus is given by 18 minus 6, which is the price, times 12 over 2. 12 are the units of Q traded, and we divide by 2 because it is an area. So it's like 18 minus 6 times 12 over 2, because this is the area of consumer surplus, which is equal to 70. While producer surplus is this one, so we can easily compute it from the graph, and it's 12 times 6 over 2. Which is exactly 36. And the social welfare in this case is just the sum of the consumer surplus plus the producer surplus. So if you are asked to compute it as well, you just sum them. (72) plus 36 equal 108. And this is the first point of years exercise. Now let's get to question 2, which is the equilibrium we have found at point 1 Pareto efficient? Why? So the question here is yes, and the reason is very simple, because in this case we are considering a perfect competitive market. So there are no, let's say, externalities, advantages, or weird things we have to consider. And simply the equilibrium we find in these conditions is always very efficient, because Pareto efficient means that this is the maximizing equilibrium, the maximizing satisfaction equilibrium, in the sense that we don't have another equilibrium which can make both the consumer and the producer better off. I mean, we can have an equilibrium in which, for example, the producer is better off in the sense that it can sell more units or to a higher price, but in this case, the consumer will be worse off, okay? And vice versa. So this is the optimizing equilibrium, and this is the reason why it is very efficient. And we can find another one in these conditions, which is better than one of the other. The third question is, the government decides to implement a specific tax on each electronic cigarette purchase. So the tax is on consumers. The tax rate is equal to 3. Find the new market equilibrium. Okay, so what do we do? Then cancel here. So now we're going to have to study the effect of the tax, which is equal to 3. On the price and the quantity traded in the market. The new price demand, which was like the older price demand, was 18 minus Q. And now we have to consider that there is also a tax of trade. So the tax is put here. This was the initial PT, right? Minus the tax. Okay, so we have 15 minus Q. And the number, while the inverse amount of producers is the same, because the tax is all on consumers, so it doesn't change anything for them. So our other equation was Q over 2, and it remains the same. Find the equilibrium and the price, we still solve this system as before. Okay. So we have 15 minus Q equal to Q over 2, and this gives a Q equal to 30, no, sorry, to 10, and the price equal to 5. So these are the new prices. And we can also see in the graph why it becomes like this, because the demand for goods we have in the graph, due to the tax of 3, will shift down of 3 units. So this is going to be the new one. This is going to be 15. This one is the new level of units traded, which is 10. And the new price is 5. The graph is not super nice, but very, you can understand it. And this is the tax rate, okay? So, what else? I'd say this is it. We can still compute consumer surplus and producer surplus, which is the last point of this exercise. And to do so, we use actually, I'm forgetting something, I think, because the price it's 5 for the, I forgot to tell you this, the price is 5, but for the producers, why it's 8 for the consumers. And how do we find this? Just we notice that 5, which is the price for the producer, plus 3, which is the tax that has been recently introduced by the government, gives 8. Okay. And so this is it. So here we have actually 2 different things. So we're gonna compute the consumer surplus and producer surplus. So the consumer surplus is now 18 minus 8, which is the price the consumer has to pay now, times 10 over 2. 10 is the new Q we have found, so the new quantity traded, and it's equal to 50. While the producer surplus is 5 times equal to 25. Okay. While now the welfare, actually, we have to consider also another factor, which is the tax rate and what the government earned from the introduction of the tax. So we have the consumer surplus, the producer surplus, but we also have to consider what's called tax revenue for the government, which is equal to 3, which is the tax rate, times 10, which are the units rated, which is 30. And the social welfare of the whole system now includes 50 plus 30 plus 25, which is now 105. So this was the last point of the exercise, and I hope it's kind of clear. And if you have questions, just write in the chat. We're going to answer immediately. There are some questions. Okay. We're going to also share with you the file with the solution, so you can review it and also you can participate for the midterm. Oh, and another important thing is that we're going to publish tomorrow or the day after on our Blab page.
Yeah, we're just going to publish the formulas.
A list of formulas for micro, so you can use those as well.
Yeah. Pretty easy.
Thank you so much, guys. Really.
Yeah. So, yeah. And also look out for like what the question you asked me before. Also, I think your approach, like the other approach you might be having also, is the one that says. So I basically skip the part that says marginal rate of substitution equals to weight like over R, and then you actually end up plugging that in the isotone and the isotone. That part we will terribly sorry. I just tended to do that very quick. So in case you need like this one isn't anything else, just write it like right afterwards and we talk about it.
Yeah, exactly. If you need any other further help, don't hesitate just text us or write us or send us pictures of the exercise or whatever, and we'll do our best to help you. And we really hope this session was useful for you, and good luck. Yeah, with the questions. So
With your session as well. It's gonna be fun. Bye guys.